Okay, so now that we've looked at the approach we're going to take for the foot setup, let's now jump over into Houdini and actually get this implemented. The first thing I want to do is apply some simple IK to our foot bone and our toes bone, and to do that I'm going to utilize the basic IK tool, a tool we created back in the technical rigging series. If you didn't follow along with that series, hopefully you have gone ahead and installed this tool with the included script that came on the DVD. So let's turn around and apply basic IK to both our foot bone and our toes bone. Now when we apply basic IK to those, we're going to get IK handles created, and we're going to get inverse kinematics chops created for us. The inverse kinematics chops we are going to keep. The IK handles aren't actually going to become our roll controls as mentioned in the whiteboard video. What's actually going to happen is we're going to create our roll controls, and then we're going to replace our IK handles with those controls. So the roll control will act as our IK handle, just we're not going to use those default IK handles that come in as our roll control. So with that in mind, let's go ahead and activate the basic IK tool. And the first thing I want to do is grab our foot as the start bone, enter, and we want a single bone in this IK chain, so I'm going to grab the foot as the end bone and push enter, and that is going to set up IK simply on that foot bone. So now if we jump in and grab our end effector, you can see that is affecting our foot bone. Undo to put that back in its default location. And let's now apply basic IK again, this time to the toes bone. Enter to select it as the start bone, and enter to select it as the end bone. And now we have our toes bone being driven by IK as well. So now that we have both of those bones driven by IK, we can go ahead and actually get our roll controls set up. Before we do that, I do want to go ahead and rename some things. Again, those IK handles are temporary. They will be replaced by our roll controls later, so I'm happy to leave those named the way that they are. But down inside the chop network, I do want to go ahead and rename our kinematic solvers over to represent what they're driving. So our IK solver is driving the foot, so I'm going to rename this to L_foot kinematics. And this IK solver 1 is driving the toes, so I'm going to go ahead and rename this to L_toes kinematics. We can now jump back up to the object level, and I'm going to go ahead and set up our ball roll control. Now to do this, I do want to inherit the orientation of our foot bone. So I'm going to go ahead and branch off of L_foot into a null. And I want this null to be positioned at the end of the foot bone. Now this is just a temporary measure. In a minute we are going to be unparenting this guy. So I'm going to jump over and grab the value that's set for the bone length for that bone. Then I'm going to go ahead and inside translate, I'm going to put a negative of this value into translate Z. That will move us to the end of the bone. We can then go ahead, keep position when parenting, unparent. That will maintain the position and orientation in the view, but giving us a completely unparented null. So let's rename this to L_ball roll underscore control. I do want to go ahead, and since we're only rotating on X, I can go in and basically set rotate X here to be 0, since it's only the other orientation that we're interested in maintaining. The actual rotation on X we can set back down to 0. Once we have that in place, I do want to go ahead and set this up so that we know it's a control object. So I'm going to jump in, give it a blue node color, jump over to the MISC tab, give it a blue wireframe color since we're dealing with the left hand side of our character. We also want to go ahead and I'm going to give this a control type of circles. And we're rotating only on X, so that means I want the orientation to be the YZ plane, and its geometry scale really needs boosting, probably up to something like that, maybe even slightly greater. Now it doesn't matter that it sits inside our geometry. If we were to switch to a shaded view, you can see that nulls actually display themselves through the geometry, so it doesn't matter that he's sitting inside the geometry. The animator will still be able to grab him if needed. Fantastic. And while we're here, let's clean things up a little bit. I'm actually going to hide out the skeleton geometry and our goblin geometry and make the viewport just a little bit cleaner. So we've got our ball roll control, and we can now go ahead and use this as the end effector for the kinematics driving our foot. So inside kinchops, on our foot kinematics, I'm going to change the end effector to now point at our L_ball roll control. Accept that. that means that this control is indeed being used to drive the IK on that bone, and that means that the IK handle is no longer needed. We can delete him out. If we take this ball roll control and we're to parent our leg IK handle up underneath it, that means when we rotate this control object in X, the IK handle would move, and we're going to get the exact motion that we wanted from the ball roll control. So I'm going to take our leg IK handle. Notice we do have keep position when parenting. I'm going to parent him underneath the ball roll control. While we're here, since this guy is going to eventually not be a control object, let's go ahead and delete the node color, and later on we'll deal with turning off his visibility. Right now I want to actually see what's going on when I rotate the ball control. So let's grab our ball roll control. When we rotate it, you can see that we're rotating our IK handle. That's causing the leg to reposition itself. Since our foot bone is parented at the end of our lower leg bone, he's repositioning himself, but since the control is the IK handle for that bone, the bone is reorienting itself, and it looks as though it's pivoting about that point. And that's really the core of this entire foot setup. We're going to do the exact same thing with the toes roll control, but the whole core of this setup is basically driving IK, if you will, in reverse. We're rotating a bone about its endpoint as opposed to its start point by using the IK handle for the parent chain and rotating that about the IK handle for the current bone, and that gives us this nice reverse foot type setup. So I'm going to zero out our rotate X back down to the default location, and let's now repeat this for our toe roll. So I'm going to branch off of L underscore toes into a new null, and this is going to become our toe roll control. So the first thing I want to do is grab the bone length for L underscore toes, and inside translate Z for our null, I'm going to put a negative of that bone length. We can then keep position when parenting and unparent, and again we can zero out our rotation in X. I'm also going to rename this guy to L underscore toe roll underscore control, give him a blue node color. Let's jump over and give him a blue wireframe color since he is on the left hand side of our character. I do want to go ahead and give this guy a control type of circles. Again, we're only rotating on X, so I'm going to give him a YZ plane, and I'm going to boost his geometry scale not quite as large as before, maybe somewhere around 1.6. So he's not quite as large as the ball roll, but he is indeed set large enough that we could see him in the view quite nicely. So we've got our toe roll control in place, and what I'd like to do now is set him as the end effector for our chop for our inverse kinematics driving the toes. So instead of IK handle 1, I want to set our toe roll control as the end effector. So now that he's the end effector, we can jump up, grab that original IK handle 1, delete him. We can see if we grab toe roll control and were to move him, he is indeed being used to drive the IK on our toe bone. So now if we took our ball roll control and keeping position while parented under the toe roll control, again let's zero out our rotate X, even though that was a very, very small value. Now if we take our toe roll control and rotate in X, what's going to happen is that our ball roll control is going to pivot about that point, rotate about that point, and so is our leg IK handle. So what that means is our leg IK handle is going to move, driving our leg. Our ball roll control is also going to move. The relationship between our leg IK handle driving that bone chain, then the bone that's parented up under that bone chain now aiming down at the ball roll control means that that whole bone is going to rotate about that point. And then because our toes bone is parented up under the foot bone, he is aiming down at that point, so it looks as if the entire foot is rotating about the toes. So we can again jump in, zero out that rotation. So now we have the ability to come in and rotate on the ball of the foot, or rotate on the toes of the foot, and that's going to drive the rest of the leg motion. The final thing I'd like to do now is set up the entire foot control, and this is going to be a custom control type. I'm going to create a circle, then go in and manipulate the points, and I want that to sit around our foot. Now, as a good starting position for the pivot point, I'm actually going to take the leg IK handles position. So I'm going to wire a node off of leg IK handle. I want to wire a null, and let's rename this to L underscore foot underscore control. Let's give him a blue node color since we know he is going to become a control. And the first thing I want to do is keep position and unparent. We can zero out those very small rotations there. And then I'm going to translate this guy down, and I want to position him at the bottom of the foot. To do that, I'm going to bring back our goblin geometry. So let's bring back our goblin geometry, jump into a side view with space 4. I'm going to translate down in Y to the very bottom of the foot. So that's going to be the pivot point that I want for this foot control. We can now go in and actually set this up to have the custom control type. Now while we're here, we can go ahead, and since this is going to be our highest level control, we can actually go ahead and clean our transform. And then I'm going to jump over, give it a blue wireframe color since we are dealing with our left hand side of our character, a custom control type. We can jump inside the null, and let's start creating that custom control. So I'm going to start with a circle sop, and I want that circle sop to be oriented on the ZX plane. If we jump into a top view, we can see that circle. I am wanting to boost maybe the radius slightly, just to take us slightly larger than the end of the foot. Now we can jump in. I'm going to grab points. I do want to make sure this is a NURBS curve, so we have access to the points. I'm going to leave this curve closed, and you may ask yourself later why I'm going to do that, because if we look at the visibility currently, with it closed, we have a solid surface. However, leaving it closed means I'm going to maintain tangency with all these points. If I had it open, there's one point I could grab and pull away and split the curve in two. When generating this control, I want to maintain perfect tangency all the way around so you don't have a distinct division. Then later on, I'll deal with deleting out that surface, if you will. So I'm going to just grab these points, and in the top view, manipulate these points so that they sit around our foot. So I'm just going to let's turn on visibility of points. Work with the points on our foot control and outline the general shape of our goblin's foot. You don't have to be perfectly accurate here. Of course, this is personally just an artistic thing. It's just setting up a control that visually makes sense. The animator can see this control and know instantly this is the control that deals with the foot. It looks like a foot, therefore it deals with the foot. But of course, it's just a representation. It does not in any way have to be perfect. And something like that should work fairly nicely. Let's pull that out a little bit further. Jump into a perspective view. Do you want to pull that in? And let's deal with pulling that in closer. Let's move that over just a tad. So there we go. That will work fantastically for our foot control. Now, if we jump back into a shaded view, we can see we do still have that surface. The way I'm going to get rid of that surface is to wire the edit that got created by moving the points into a carve sop. If we wire that into a carve sop, what that's going to do, even with the default settings, is going to break that curve in such a way that we lose the surface on that curve. So that will work fantastically for us. We can now go ahead and wire that into our control, and that's going to apply that blue wireframe color. If we jump back up, we now have that nice blue control object working fantastically for us. So this is going to be the master parent of the rest of our foot rig. That means we need to parent our toe roll control whilst keeping position to our foot control. So let's go ahead and parent our toe roll to the foot control. I do want to zero out the very small value that got created on rotate X. So that means we can come in, we can grab our foot control, and if we move that, that's going to move the entire foot. If we rotate that, the entire foot is going to rotate based on that control, because we're rotating all of the IK handles that are driving the entire foot leg setup. So we can rotate our foot based on the heel. We can then come in and we can grab the roll control, and we can roll based on the ball of our foot or the toes of the foot. And we can actually come in, roll based on the ball of our foot, then grab the foot control, and we still have positional control maintaining that relationship there. So I'm going to undo that back down to its initial setup, and I now want to deal with setting up the twist effectors for those bones. So let's hide out our geometry, and let's see if we can get this to show itself the issues that occur sometimes with the twist on the bones. So if you pay very close attention to these two bones as we rotate up in X, eventually we should hit a point, should somewhere hit a point where they want to spin round. doesn't appear like they're wanting to actually do that now. Let's see if we can get this guy to cause it. That's actually fantastic. In the current orientation, in the current setup, it's not actually causing a problem. It can become a problem sometimes because obviously there's nothing telling our bone how to orient itself based around its z-axis. All it's doing is orienting itself on its x-axis to point at this point, which means it can actually spin round occasionally. So just to be safe, even though currently I can't actually get this to demo the effects, which is kind of interesting because when developing this it was very obvious, the effects. We can still go ahead, set up twist controls and make sure that everything is going to work perfectly rather than hoping it works perfectly but not really ever being sure, and maybe having an animator that hits a problem in a certain pose where that foot is going to twist, and that will cause obviously horrible deformations because it's not acting properly. So let's go ahead, excuse me, let's go ahead and I'm going to branch off of the toe roll control into a new null. I'm simply going to translate this null up in Y very slightly and give this the name of L underscore toes IK underscore twist effector. We can then do the same from our ball roll control, so I'm going to branch off into a new null L underscore foot IK underscore twist effector. Again, I do want to translate this up slightly in Y. Now the distance here doesn't matter, of course, because we're simply aiming this bone up at this particular control, and obviously since we're only rotating about X, that means that no matter how far we position this in Y, that's going to maintain the exact same orientation, the exact same plane when we use it as a twist effector. So the actual amount that we translate this in Y in this particular case doesn't have an effect. So we've got those two guys in place. We can see what happens when we rotate our foot about that point. You can see that we can tell our foot to always aim down at that point, and that means that we're going to prevent any possibility of the bone spinning when it shouldn't be spinning. And again, with the toes as well, they'll always be told to aim down at that point, whereas there is a possibility, of course, that they could cause some weird spinning in certain instances if we didn't do that. So I'm going to jump down inside the chop network, and on our foot kinematics, of course, driving the foot bone, I want to reference the foot twist effector. So let's grab our foot IK twist effector and accept for the twist effector parameter. And on the toes kinematics for the twist effector, I want to grab the toes IK twist effector. So now there will never be a situation where that will cause nasty twisting, because that bone will always look at that twist effector, and the same for the toes bone as well. So we can go ahead, we can clean up our network. So I'm going to go ahead and turn off visibility and selectability on our original IK handle plus those two new twist effectors that we created. I'm also going to go ahead and I'm going to lock some of the parameters on our controls. So our foot control, we want translates, we want rotates. I don't want to be able to scale that control, change the pivot or uniform scale. Our toe roll control, we only want rotate in X, so I'm going to lock translates, scales, pivots, uniform scale, rotate Y, and rotate Z, and the same for the ball roll, so that's translates, rotate Y, rotate Z, scales, pivot, and uniform scale. So again, we now have that foot setup in place, and this foot setup will work with the stretchy IK. So of course, if we move this down, it will stretch our leg, and if we tell the leg to not stretch, if we grab our upper leg and turn off its stretchiness, what's going to happen, and this makes obvious sense, we can pull this down. It's going to pull the controls away from the foot, and the foot will point down. This is the behavior that I want to happen with this control. If we pull this too far, I want the foot to point down to indicate, you know, we've pulled this too far. It's still trying to reach the controls, but it can't. So that's the exact behavior that I want this foot control to have. So with that, that will conclude the setup of the foot control, and that's actually going to conclude the entire setup of our left leg and foot. Thanks a lot, everyone.